Hello, in this video we will continue extending our view layer and today interconnected with the HMI layer. So, as you may recall, in the previous video we have done a system, a basic conveyor loop composed of 4 conveyor segments, and we did this with FBDK tool. So I'm starting again the tool by double click of FBDK to jar and accepting terms and conditions. And once the tool is up and running, we can find our CNV loop we have been previously doing. So again, our CNV loop is composed of 2 devices as shown in the tree on the left hand side, and we have developed this view resource. The view resource has our basic match view blocks and space blocks to arrange view layer to form this nicely looking, well, square or rectangle. Let me just start it once again by the right mouse click on the root, and we see CNV1, well, 2, 3, 4 appearing in the screen, exactly as was designed in the beginning, 4 conveyor segments. So coming back to this FBDK tool, we have defined last time 3 data inputs, leaving some of the data inputs empty. I would like to start with connecting some of inputs still here as the constants, and those would be style inputs. If I make a right mouse click and connect default value, which is none, vStyle none, I may get a question how and what values I can provide here instead of none. To answer this question, we can check enumeration type for vStyle. How can we check it? Well, we may find vStyle block or type, better to say, defined in MVA folder of FBDK tool, and if I double click it, it will open in a separate tab, and from this view we can check all the possible basic values vStyle can provide to us. As we can see, the first one is the default value none, but there are additional values like bars, slider, cylinder, ball, disc, etc., which you can use defining your basic visualization layer structure. Let's suppose that out of a given list we would like to have different components, different views appearing on each of the conveyor. Let's say if we start with conveyor 1, it would be just a disk coming to conveyor 1. Then we would like to have a ring, so disk with the hole appearing here, like it was something happening. And next stage of process comes, and then on this 4th conveyor there would be peg ring, so some assembly operation has taken place, just as example, and then CNV2 would contain a pallet, just in our case illustrating that some packaging process has taken place. So how we can do it? For this we will need to use dedicated values of vStyle, which are once again disk. We can find here ring, then we can find peg ring, joining ring and the peg, and a pallet. So coming back now to our conveyor loop, let's edit the style, and for the CNV1, which is on top in our picture, it would be edited to disk, all the capital letters for the disk. Then conveyor 2 in our view comes on the left hand side here. So here should be a palette, as the product will travel whole loop. So let's provide for the style here corresponding value, which is a palette. So I'm just typing palette in capital letters after the hash tag for the enumeration type of VStyle. Pressing OK. So we have the value defined. Then conveyor 3 is located on the right hand side over here, and in this case there should be ring coming. So coming back to the style of CNV3 and placing there the word ring, capital letters. And finally, for conveyor 4 in this structure, let me resize it, relocate it, we will be placing peg ring as the value of from the VStyle enumeration type. Peg ring comes here. What other parameters we have for the basic match view? Background color, as we ran it previously, is blue, so this is background. Inputs available on each block, let's keep it blue, the default color. However, let's try to change workpiece color. I make again right mouse click, connect default value and try to edit. What I'm about to edit is the three variables, which stands for red, green and blue as the colors of the workpieces. So let's, by default it's a black color, so absence of the colors. If we put all 255, this should give us white color. So let's say this would be a value for the first conveyor, to have as a workpiece color white color. Okay, so let's then proceed to the next block in our structure, which is CNV2. In the loop it would be the last conveyor, but let's say that it should be giving us the red color. So I'm just highlighting or setting maximum the first byte of this array RGB red 255. Then for the third conveyor, again same three parameters. Let me put here for the green RG, second parameter. On the third conveyor there should be appearing green workpiece. And finally, let me mix here. I wouldn't be placing last parameter because it's blue color, but I will mix instead red and the green colors by setting those to maximum. Of course, we can set here values from 0 to 255, giving different intensity of each corresponding color and deriving some new colors by mixing red, green and blue. So this is our current values, but how and what we would be providing from HMI. Let's say that HMI would be giving us position for each of the conveyor segment. So I'm going then, but before let me save it, what we have done. I'm going back now to the HMI folder, and in HMI folder we can check what can be used to provide the position value to the conveyors. Well, as I said last time, there are two categories of blocks which are standing out from other blocks. Those are the blocks prefixed with in and the blocks prefixed with out. In blocks are used to provide values inside of application in this case, and through the HMI in this case. and out to get values out from the application. So let's use first, default block in any and check how we can apply it to provide position. I'm going now to the HMI resource panel, or in this case it's resource, and let's add for each of the position 4 elements. First one would be, let me first stop the application what was running, and now I am adding it once again in any on the HMI resource level, adding, and let me call first one as CNV1 POS block, and adding them 3 times more, CNV2 POS position, and here comes CNV3 POS, and finally for the fourth one, CNV4 POS. Blocks are added, and same as with the HMI, as we did with the view, connecting in particular order, so these converts would be coming in particular order, one after another in the view layer. The same applies to the HMI, so depending on in which order we connect them, in that order they would be appearing those in any blocks. Let me just use this numbering 1, 2, 3, 4 to dictate us the order for this moment. So I interconnect cold with init, and then connecting one after another all the init outputs to the next init inputs. Then for these blocks it's important that QI input would be set to 1 to enable the block, so that we will be able to use them. So I set default values as 1, update the values to 1. Then there comes W, which is a width, the field where we will be introducing the value. So once again, to remind, I can double click on the block to open it in the new tab, and then I can check what means this W by selecting this uint and looking at the bottom in the comment what it says, text field width in charts. So how many charts would be allocated to provide the value. So I may say now that the position here is changing from 0 to 100. I can also double click now on the match view and go to the position, mechanism displacement to remind us, and this displacement is measured in terms of percentage from 0 to 100. So what it tells us, this 100, is that for the in any W input with input, it's enough 3 symbols for the width. We go back to the resource and connecting to the W, 3 would be enough, but let's just to have a bit wider space, put 4 for the moment, 4 to all the blocks as another constant input. Let me modify it for all the blocks. Okay, and finally there comes type input. I switch back to in any tab to check what it means. It's W string, and it says that it's a data type name. So since it's universal block, this in any, and it can provide to our application any type, we can configure this block to serve for any type, but in this case we need to know what should be the value position is given to us. Well, how to check it? Very easy. We can go to the match view here in conv loop and check what is the type of the position. Well, it's unsigned integer uint. Uint, that is what we have to provide here for the type input. In the quotation mark, I enter uint. So this is information once again we received from POS type uint. And now, since we would like to provide for this converge segment position, we need to specify corresponding type. Again, this applies to all the other blocks, as all of them provide position. If you need a boolean, you would rather type bool there, but in this case uint goes for all the blocks. Still, there is a possibility to specify initial value. Well, let's put, again, it comes in the quotation marks. Let's put for as initial values for all the blocks 0. That this would be initial position where we initialize our conveyor, where things are entering our conveyors. Perfect. We have been creating now our HMI basic blocks in any. Let's take a look how it works. Well, obviously it's not yet interconnected with view resource, but just we will run in a moment the application to check how it would appear. I save first the application, and on the root, making right mouse click, running CNV loop. Let's see what comes. We have 4 fields, and as they were introduced, 0, 0, 0, 0 comes here. What else we can see here besides that those zeros handling? Well, if we change, as I said, nothing would happen. When we work with this in any, we put the value and press enter, but well, nothing, as you see, happens because we didn't interconnect it with the view layer. But we can see also some changes already on the view. Here we see our white disk, then comes our ring, then peg ring, and finally red palette is located here. And what you can also notice, which maybe was not so apparent before, that disk comes in the top and palette appears at the bottom of the corresponding conveyors. So in a way, this is indirect signal to us that we have correctly specified orientation of our conveyors. So disk would be going from the left to the right, then ring would be going from the top to the bottom, peg ring from the right to the left, and finally palette would be coming from bottom to the up. So this is already can be seen here that we get also the right orientation for that functionality. Good. But let's now interconnect our fields so that as we will be providing values from 0 to 100, we will see corresponding objects moving on the conveyors here. I'm coming back, stopping conveyor loop, system, process terminated. And for interconnecting the things, we need to go to another important folder here called net folder for internetworking. Since we run our application now in a single computer on the single screen, it's enough for us to use a local publisher and local subscribers. There are servers, client, local publish, subscribe blocks available for actual internetworking between the machines, computers. Here for the local we have just subl and publ blocks. Then you see that all of those blocks here, or most of them, have some numbers at the end. This number signifies how many data inputs and therefore outputs those blocks should convey. For instance, publ 0 means there are no any data to be conveyed, but just event. Something has happened in the other part of the application. On the other hand, publ 1 would be used to convey some value to, again, other resource or device run locally. And same applies for the subl blocks. And those subl and publ go in pair usually. Well, we can have one publisher and several subscribers, but what I mean by pair, that the suffix, the number of the block should correspond to each other, so that as you convey certain amount of data values, the same amount should be received on the other side. So these numbers therefore should match. And as in our basic example, we would like to report a position of workpiece on the conveyor, we need to publish just one value. So I would start publishing at HMI level, and since we just need to convey one value, one position, I just add publ one block here, and I need to add these publ blocks for each of the conveyor. So let me name therefore CNV1P, so that it would be position, but it should be different name. From pos I cannot type pos, so I just add CNV1P to denote the position of conveyor 1. Okay, publisher. But each of these in any blocks must publish the value, so I add other 3 instances of publ1, giving each of the instances unique name as with the index of conveyor CNV3P, and finally comes CNV4P position. Okay, what we can see, and as we develop applications using IEC61499 standards, we still need to initialize the blocks. One of the approaches could be to check what is the last init output that was not initialized. So it is this init O. Well, let's take it, last not connected init O, and connect it now to the first publisher block. Then we need to repeat the same idea for the conveyor 2 position publishing, conveyor 3 and conveyor 4P blocks. Okay, at the bottom we are given our position publishing. Well, here publisher blocks, since it's publ1, has only one SD parameter, send data. I interconnect output block of output data to SD1. Okay, it comes like this. Same as goes for the data output out of CNV pos for second conveyor. Let me once again drag and drop it. Okay, and I can make it look a bit nicer if I want. And for the conveyor 3 pos connecting to SD1, And finally, for the output out of CNV4 pos, connecting to SD1. Okay, that comes our 4 publishers connected. That's it, basically. We have all blocks initialized. We have also the data input for send data. Then there is another input ID here for the publisher blocks. If I double click now to the publisher to open it in the separate tab, we can check that this is WString parameter ID and its local group name. So by this name, subscribers can find and subscribe to the publisher blocks. However, here is another saying. Default is FB instance name. In other words, you can use function block instance name for making interconnection between publisher and subscriber blocks. What does it mean? It means that in the view resource, if and as we would like to subscribe to the publisher block here for conver1, we just need to use the same instance name. In this particular case, it's cnv1_p. So on the view resource, we should have a subl1 block with the same name cnv1_p, and it will mean that data sent with this D1 would be appearing for those subscriber blocks having same instance name. So here you do not need therefore to use this ID input of publisher block, local publisher. Let me go to the view resource and add subscriber blocks. As you may guess, I go to the again net folder, so just to check with you that it's from the net folder, and we need to add 4 instances for subscribing the positions, and I would be calling them absolutely the same, capital letters cnv1_p to subscribe to the publisher of in any providing us values for the first conveyor. Then I add same following same idea the subscriber for the second conveyor. Then for the third, let me put it somewhere here, the block, I can move space now a little bit up, so and finally comes CNV4P block. Okay, again just a bit rearranging for better visibility. So again, logic could be the same as in the HMI resource. We first check that all the necessary blocks are initialized. Therefore, again, I'm finding last init O, init output not connected, and drag it to connect it to conveyor CNV1P block. Then I initialize all the consequent blocks, connecting init outputs. So this is done. Now what else we need to do? We need to provide the values for positions. Now I take this read data 1 and connect it to the pos. So now what we will enter in any block, it will go to the send data of publ1 block. It's named cnv1_p. Therefore, all the subscriber blocks, subl1 in this case, bearing the same name, cnv1_p, will get this data from in any blocks propagated and coming to the position here of match view block. So now I just have to interconnect positions here for CNV2, yes, checking the indexes that I am going correct order. Okay, let me just drag and drop it here and rearrange it, RD, and so that's it. I have connected all the publishers blocks to the corresponding subscriber blocks by having unique and matching names of the blocks, Publ and Subl_1. Application is ready. Let's see the result. I save first before testing the change that is there and running the system. So let's see how and if I will be modifying the values if something would be moving. Let's say I would like to, for the conveyor 1, to put it in the middle, this disk, what I have it there, I place 50 and then I need to press enter on the keyboard. I press enter on the keyboard and let me try first to restart it. Okay, nothing yet happens, no move. So let me come back, stop the conveyor for a moment and see if, yes, it's a typical mistake made, and I'm not an exception here. I have initialized all the blocks with the init inputs outputs, but I forgot to provide request event, and this request should be coming from the indication event. So we have connected initialization data, but I have forgotten to connect events. So indication of the block comes to the request of each of the corresponding blocks. Let me a bit try to maybe adjust it. Yeah, so just to see better. Okay, and then indication goes to the request here. Okay, here it is connected, and indication goes event here. So connected. Besides indication events, we need to come back, and here are the requests events which are hanging unconnected. So now indication events of the subscriber blocks should be also connected to the request events of conveyor blocks. So in this case we have been integrating everything data and the events. Okay, great. Now I go save it with checkbox XML and try to run the system again. Now I put the same value 50, and as I press enter I would expect that this disk would be moving. Let's see if that's the case. Yes, now it seems to be working fine. Let me check it with the conveyor 2. Remember, conveyor 2 is here. Let's say we would like to move 25%, so 1/4, 50 is in the middle, 25 would be 1/4. Let me press now enter, and you see it is moving. We can put, like, let's say 33% quarter for conveyor 3, and well 66%, so 2/3, about 2/3 our peg ring appears here. So today and in this video we have seen the use of basic publisher and subscriber blocks for sending data, reading data and delivering it to the corresponding positions. We saw that it's important to initialize the blocks, provide the values to each correct input, but it's also important to, in the event-driven architectures supported by IEC61499 standard, to have events propagating as we entering the values to get the result. Next time we will continue with the model layer and start to get behavior of the controlled object in those models. Till the next time.